Hi everybody, today let's look at stationary point. Stationary point is a point where the dy by dx is equal to 0. At that point, at stationary point, the dy by dx is equal to 0. That means the gradient of tangent is equal to 0. So we have three types of stationary point. Maximum point, minimum point, or infraction point, or sometimes we call it point of infraction. These two, maximum and minimum point, we also can call them turning point, because that is a point where the graph starts to turn its direction. This is a maximum point and this is a minimum point. This is a minimum point. This is a maximum point. Okay, for point of infraction or infraction point, that is a point where the graph starts to change its concavity. But some of the infraction point, they are actually not stationary point because their dy by dx is not equal to 0. Okay, let me show you here. Look at this one. Okay, now I have a graph here. F of x is equal to parentheses x minus 3 raised to the power of 3 plus 3. Okay, this is a curve. So you will notice that, okay, the red color curve representing the gradient of the tangent. Or you can look at this. This is the gradient of the tangent. Let me show you that here. Okay, you can look at this value. This is the gradient of the tangent, or this value. Okay, now let me move the point. You try to observe this value. You will notice that it becomes smaller and smaller, right? Smaller and smaller. Smaller, decreasing. Until this point, it becomes 0. Smaller and smaller, then increase again. Just now decreasing, then increasing. That's point which the graph changes concavity. We call it point of infraction. So you will notice that this point of infraction also a stationary point because its dy dx is equal to 0. The gradient of the tangent is equal to 0. But some of the point of infraction, they are actually not stationary point. For example, now you look at this one. Oh. Okay, so this is a curve for x cubed minus 3x squared plus 4. And the green color curve is the gradient of the tangent. Now you focus on this value. This is the gradient of tangent, or this value. They both representing the same thing, the gradient of the tangent. Okay, for this point, this is a stationary point. This is also another stationary point. This is local maximum, or we can call it maximum point. This is a minimum point. Now, the gradient of the tangents decreasing, right? Decrease. Keep on decreasing. And until this point, you will notice that the gradient of tangent start to increase. Or I move it a little bit up for you, and then you can see this is a gradient. Decrease, then increase. So this is a point of infraction, because this is a point where the graph changes its concavity. Concave down to concave up. Concave down means, okay, let me write here, concave downward. It means the graph like this. The d2y dx2, because it's decreasing, right? The gradient of the tangent less than 0. So concave upward, like this. The gradient of tangent increasing. The d2y dx2 is greater than 0. So this is a point where the graph changes concavity. We call this as an infraction point. But in this video, we are not focusing on this type of infraction point, because we are just focusing on stationary point. This is not a stationary point because its dy dx is not equal to 0. Okay, now let's go back to our note. To test a turning point or a stationary point, is a maximum point, minimum point, or point of infraction, we can use two methods. First, derivative test. It means that we look at the changes of the value of dy dx before and after the turning point. For this case, maximum point, right? You will notice that the dy dx from positive change from positive to negative. Positive, then become 0, become negative. So this is a maximum point, because this is decreasing, right? The gradient of the tangent. That's why the d2y dx squared is less than 0. So if you don't want to use the first derivative test, you can look at the value of d2y dx2 at the turning point or at the stationary point. If it is less than 0, that means that is a maximum point. So if for minimum point, it just go another way. You will notice that the gradient of tangents or the sign of the dy dx before and after the turning point, this is a turning point, change from negative to positive. So if you see the gradient of tangents or the sign of the dy dx change this way, then you know that this is actually a minimum point. Gradient of tangent go downward, then become horizontal, then go upward. So the gradient of tangents increasing, right? That's why d2y dx squared will be positive. You can find the value of d2y dx squared at the turning point here. So if we get positive, it means that minimum point. Now let's look at the third types of the stationary point. This point is not a turning point. We cannot call this as a turning point, but this is a stationary point because the dy dx is equal to 0 as well. So in this case, this is also a point of infraction. Infraction point. You will notice that the sign of dy dx does not change. From positive, then it becomes 0, then it becomes positive. So just now, from negative to positive or from positive to negative, right? For this type of point of infraction, it will keep the same. The sign of the dy dx will remain the same before and after the turning point. This is not turning point. Before and after the stationary point. So you notice that here positive, here also positive. This also the same case, negative becomes 0, then negative. The sign of dy dx remain unchanged before and after this stationary point, this point of infraction. So this is a point that I showed just now. We also call this point as point of infraction, but this is not stationary point. So we are not focusing on this type of point of inflection for this video, because in this video we are focusing on stationary point. Okay, let's look at few examples. Find the coordinates of the turning point of the curve y equal to x cubed minus 3x squared plus 4. Okay, I have drawn the curve for you, so you know that we actually have two turning points here. We have two turning points. They are also stationary point, right? We can call it stationary point or turning point. And we actually have another point of inflection here, but we are not going to find this point because this is not a stationary point. The question is only asking about turning point, so we only need to find this and this. Y is equal to x cubed minus 3x squared plus 4. So we know that turning point is a stationary point, right? So that means their dy dx will be equal to 0. So I find dy by dx first. I differentiate this function first. Dy by dx. 3 bring down here, copy the x, power you have to minus 1. I hope that you still remember this process. 2 times 3 you will get 6. X copy, 2 minus 1 you will get 1. Okay, you don't have to write the 1. Differentiate a constant, you will get 0. So this is a gradient function at turning point. Dy dx is equal to 0. Okay, it means 3x squared plus minus 6x is equal to 0. So we are going to find x. I just divide this whole equation by 3. So I will get x squared minus 2x equal to 0. Make the number become smaller. Easier for us to solve it. So I do the factorization. Factorize the x out. X minus 2 is equal to 0. Okay, now we know x is equal to 0 or x minus 2 is equal to 0. X is equal to 2. Okay, since the question asks us to find the coordinate of the turning point, now we only have the x coordinate. We need to find y coordinate as well. So how do we find y coordinates? We need to substitute this value into this function to help us to get the y coordinate. Okay, when x is equal to 0, so y is equal to 0 cubed minus 3 times 0 squared plus 4. We just substitute the value of x, which is x equals 0, into this function. Change all the x becomes 0. 0 cubed minus 3 times 0 squared plus 4. Okay, so the value of y is equal to 4. So that means the coordinate of this turning point is 0, 4. Okay, we do the same thing for this point. When x is equal to y is equal to, we are going to substitute this value of x, which is equal to, into this function. 2 cubed minus 3 times 2 squared plus 4. 2 cubed minus 3 times 2 squared plus 4. Okay, so this is 8. You will get 0. Okay, so the coordinate for this turning point will be 2, 0. Okay, this is the point. Okay, so turning point is, so we have two turning points here. They are 0, 4 and 2, 0. Okay. Now for part B, the question asks us to determine each of the turning point. Okay, determine whether each of the turning point is a maximum point or minimum point. It means that we want to determine the natures of this turning point. Okay, we are requested by using the first derivative test and also second derivative test. Okay, let me show you both here. So we have gotten the turning point 0, 4 to 0. Let me erase this part. Let me show you the first derivative test first. So this we need to draw a table. Okay, so this is a table that you need to draw so that you can use the first derivative test to test whether the turning point is a maximum or minimum point. Okay, let me test this point first. 0, 4. So first, place the x value for the turning point over here. And then choose a value smaller than this value a little bit. So how about we use negative 0.1. Okay, and this one slightly bigger than this value. 0.1. This is negative 0.1. It means that we want to find. Okay, explain this way for you. This is a turning point, right? We are testing this turning point. We want to know this. At this point, the gradient is at this 0. So we want to know either this turning point is this type of turning point, which means that positive 0 negative, or negative 0 positive. We want to look at the changes of the sign of the tangent. Okay, so we want to find the value of dy dx. Actually, here the value of dy dx is not very important. The most important thing is the sign of dy dx. So you can use your calculator to help you to find this one. So we are going to use this gradient functions to get the sign of dy dx. What you need to do is just key in this function 3x squared minus 6x. 3x squared minus 6x. Okay, then you ask the calculator to calculate for you when the x is equal to negative 0.1, what is the value of dy dx? When the value of x is equal to 0.1, what is the value of dy dx? Okay, press calculate. Then key in the value of x you want, negative 0.1. Negative 0.1. Press equal. Okay, you will get 0.63. Write 0.63. Then press calculate again. Okay, how about we test this one? 0. We should be able to get 0. If this is not 0, it means that our answer is not correct. Because this is a turning point, right? So we know that the dy dx is equal to 0. Press equal. You get 0. Okay, now let's go to this 0.1. Press calculate. 0.1. Press equal to and equal again, which is negative 0.57. So it's right. We can do this way, so faster for us to get the value of dy by dx. Okay, let me write down the value. This is 0.63 and this is 0. This is negative 0.57. Okay, positive 0, negative. Positive, the gradient go upward like this. 0, the gradient horizontal. Negative, the gradient go downward. First from here, we know that this 0, 4 is a maximum point, right? Maximum point. Okay, so how about this 2, 0? We do exactly the same thing. Okay, let me show you here. Let me change this point become 2, 0. Okay. So if this is 2, 0, now we are testing this turning point. We write 2 over here and a number slightly smaller than 2, a number slightly bigger than 2. So I will use 1.9. And this one 2.1. Okay, so now take out your calculator. The function still here, so you don't have to key in again. Just press calculate, then 1.9 equal 2 times, then you will get negative 0.7. Press calculate. Okay, let's test 2. We should be able to get 0. Then calculate again, press 2.1. Oh, sorry, this 221, 2.1 equal. Okay, you will get 0.63. Let me write down all the value that we got just now. Negative 0.570, 0.63. Okay, negative, right? Oh, yes, correct, negative. So this sign is negative, 0, this is positive. Negative, the gradient go downward, 0 horizontal, then positive, the gradient go upward, incline upward like this. So from here we know this is a minimum point. Is a minimum point. Okay, this is the first derivative test. Now we are going to try another method, second derivative test. So our answer correct, the 0,4 maximum point, 20 minimum point. For the second derivative test, we need to do again, differentiate this again. We differentiate it for 2 times. This is the first time, and we need to differentiate it again. d2y dx squared. But the process still the same. 2 times 3, you will get 6. Copy the x. Power, you have to minus 1, which you will get 1. You don't have to write 1. Differentiate 6x, you will get 6. Okay, let me check. Now, we are going to find, I hope that you still remember this, d2y dx2 less than 0. It means that less than 0 maximum point. In this case, d2y dx squared greater than 0 minimum point. Okay, now we are going to use this one to test it whether this turning point is a maximum point or minimum point at point 0,4. d2y, oh, let me write again, d2y dx squared is equal to, we just use the x coordinate. Substitute the x coordinate here into this second derivative. 6 times 0 minus 6, you will get negative 6. Negative 6 less than 0 maximum point, right? 0,4 is a maximum point. Okay, correct, right? So we do the second, we test the second turning point, 20 at point 20. d2y dx2 is equal to, we are going to substitute this x coordinate into this function. 6 times 2 minus 2, so you will get 6 greater than 0, right? So it means that 20 is a minimum point. Okay, so this is a way how we determine the natures of a turning point. But when you use a second derivative test, right, you have to be careful. Let's say, okay, this one I think should be no problem, right? I just show you just now how do we use the first derivative test to test the natures of a stationary point. So if you use second derivative test, if you get the value of the second derivative is greater than 0, no problem, we know that is a minimum point. If we get the value of d2y dx squared less than 0, that is a maximum point, right? This is a minimum point. This is maximum point. But when you get the value of d2y dx squared equal to 0, it is inconclusive. That means we still cannot make conclusion. We cannot say that, okay, this is a point of infraction. Sometimes it's not a point of infraction. So if you get d2y dx squared is equal to 0, then we have to proceed, go back to this, use the first derivative test to see whether that point is a maximum point, minimum point, or inflection point. Okay, so for this video I stop here first. I will continue in the next video. See you next time. Thanks for watching. Bye bye.